This is LoFi 25. We have a wonderful set of speakers coming in today. Uh, First speaker needs no introduction, but I will still give him an intro. He has been in this space since the very first days as a pioneer in Local First, hosts the Local First FM podcast, founder of Prisma, and is also building Live Store. And he'll be telling us a lot more about it and a secret announcement in collaboration with Jeff Martin. Johannes, why don't you take it away?
Yeah, thank you so much for having me. Super excited to be back. I think I've already had the pleasure once.
Yep.
Uh, and kudos to you for being so consistent of hosting this community and making this happen. And I'm very certain that you've introduced a lot of people to the our little corner of the internet, local first.
I appreciate that.
And I think that's what we're all trying to do is like helping, inviting more people and making this dream that we're having, making that come happen. And as you've mentioned, I'm excited to share a little announcement today that my friend Jess Martin, who's currently on a plane, so he can't be here live with us, but he's very much with us in spirit. And he might join once he lands. And so, in collaboration with Jess, I've been working on a resource for I think close to half a year at this point. That we've coincidentally, when we didn't quite had in mind the time for this online meetup, we picked the 29th of April as a launch date, and later we realized, oh, this is actually the time of the meetup. And so we thought, okay, why don't we just like announce it here? So I've just a couple of minutes ago, I've just uh, launched the tweet here, which kind of gives you the idea what this is all about. This is about a landscape resource that aims to provide a better overview of the by now like pretty sizable amount of technologies with all their different trade-offs, and aims to give you a single spot where you can go to and get a better idea what the various technologies are about. So it's now online on localfirst.fm/landscape. And this is where you can click around. There's a number of different technologies already in there to not
Johannes,
pick
you
any
haven't shared
favorites.
your screen yet.
Oh, that is a very good point. Well, that shall be changed. Okay. Well, classic. Uh, so I was just pointing at the announcement tweet, which you're invited to if you're using X to like and repost there. It's also in Blue Sky, and we might share it on other places as well. So now that I'm sharing my screen, this is what it looks like. It is a overview landscape resource that gives you an idea of the various local first technologies, and technologies not just purely local first, but also sync engines, etc., that are adjacent to local first as well. And already houses a bunch of different technologies. To not pick any favorites, we have chosen the a random order when you land on it. And to hand over the word to my friend Jess, who's pre-recorded a quick video to introduce this. I'll quickly let Jess speak.
Hi, I'm Jess, and I want to introduce you to the Local First Landscape. Local First Landscape is your one stop shop for all the technologies that you might be considering in order to build a Local First app. There's so many different ways that you could build a Local First app. There's sync engines, CRDT libraries, there's full Local First stacks, there's reactive databases. Where do you even start? We designed the landscape so that it would be easy to explore and find the technology you need. Let me show you some of the cool features that are available. First off, if you want to zoom in on some specific technologies, you can use these filters columns on the left over here to filter down to just a few options. So let's say that you wanted to build a React Native application. You could come down here to Frameworks and choose React Native, and it filters to just tools that support React Native. And let's say you wanted to build something that communicated peer-to-peer. I narrowed it down to P2P React Native, and you can see that these are the four technologies that support that. In addition, once I've narrowed it down, I can share that view with a colleague by clicking this, which copies a link to my clipboard, or I can open a QR code just like that. Pretty easy. Some of these terms, as you're looking through it, might be pretty unfamiliar to you. So underneath any of the filters, you can actually click more about this feature. And we took great pains to try to describe what each one of these terms means. So there's a doc that walks you through an explanation of all the different terms that are used in the sidebar over here. You can also get detailed information about each technology just by clicking on the header here, find out more about each one of them. And all of this data is actually hosted on GitHub. So we worked with the individual technology authors to describe the technology using their own terms. And so they've made it available on GitHub. If you had a new technology that's not listed that you want to support, feel free to open a PR, or you can actually go through and suggest edits to the existing technology that's up there. We're pretty excited to have offer this resource to the community. It lays out all the different local first tools and how they differ from one another. We hope you find it really useful. So go build something great.
Awesome. Well, thank you, Jess, for this amazing collaboration. And yeah, hope you all find this useful. And we very much welcome any feedback. And would be really appreciated if you help spread the word about it on Twitter or Blue Sky. So, well, that is part one, and I'm now removing my local first FM hat and putting on my LiveStore hat. But in case there's any brief questions, happy to answer them. All right, I count that as moving on. All right, perfect. Cool. Yeah, so I'm very excited to kind of give part two of a talk that I've given quite a while back about Riffle, I believe, back then. And yeah, this is sort of like a multi-chapter saga at this point. Unintentionally made a pun here about sagas because it is sort of related to Redux in a way, as we'll find out throughout this talk, and as whoever has used Redux in earnest might also have come across Redux sagas. So that was an unintentional pun here. But a different way to kind of frame this is through the lens of event sourcing, goes by many names, or for local first apps and syncing in general. There's always the question like, what do you sync? And with LiveStore, I've been really exploring what some refer to as right path syncing, and we'll come to talk about this. I think that's like a way to think about building synced applications, local first apps that nicely complements a lot of the other technologies that are out there. So yeah, for those of you who don't know me, I'm Johannes Schickling. I'm based here in wonderful sunny Berlin. I am doing a few different things. You might know me as the host of Local First FM, but I'm also aspiring to build really great software. And I'm doing that by working on this music app called Overtone. I'll share more about that in a second. And I'm doing that all under the umbrella of Over Engineering Studio. I think this started with like a funny comment on YouTube where someone said like, well, where I've given a talk about Riffle and they said this is the most over-engineered thing I've ever seen. And since then, I'm wearing it as a badge of honor. And yeah, all of this goes hand in hand working on Overtone. I couldn't have built Overtone without the data foundation, which is now LiveStore. And I couldn't build LiveStore without having really high goals to achieve. And Overtone sort of makes it for like a very nicely symbiotic relationship. So Overtone, I won't talk much about this here, just for your orientation. This is the foundational app that I've architected all around this. So as you know, with software, it's all about requirements, and Overtone really dictated the requirements for my data layer here. Overtone aims to be like a kind of a general purpose universal music app that works with anywhere where your music is coming from, streaming services, your own music library, etc. It's been honestly a bit on the back burner over the last couple of months as I've been focusing on the sync part of LiveStore, which is necessary for Overtone, but I'm looking forward to coming back to that soon. And yeah, also, if you haven't done so already, would greatly appreciate your feedback on Local First FM, where I'm inviting a whole lot of different voices in the local first space, and already had a couple of really great guests there. And there's a couple of really cool podcast episodes in the pipeline as well. So without further ado, let's talk about trade-offs. And this is really what it's all about in software. And the first thing I've learned in my computer science university was that the professor went on stage and said, like, hey, the most important thing you're gonna learn about computer science is two words: it depends. Now you can leave. You can go into the industry. You now pretty much know everything that you need to know. And it couldn't be more true for data management overall. And all the different technologies, they're fantastic. But I think what is very important to understand about them is how they're different. What are the trade-offs? How were they designed? And then you can work backwards from those trade-offs. Is this a good fit for the app you want to build or not? And LiveStore is really like a traversal on one particular set of trade-offs, which I want to talk about today and give you an idea of like the pros and cons of those trade-offs. So kind of zooming in on a bit of a hierarchy of different architectural approaches, how you can build a local first app or a synced app is high level. Think about like, how do you want to think about your data in the first place? Do you want to think about your data more from like a document perspective, where CRDTs or OT, etc. This is a great approach to think about your data or to work with your data this way. Or if you rather want to have the full capabilities of a database, so if you want to think about your data more in a database oriented way, this is where this kind of emerging category of database sync engines is interesting, and what I've been exploring with event sourcing to kind of rebuild a database on the client from the writes. So I want to focus more on the database oriented path and zoom in even further, since there's different ways how you can go about this, sort of the chicken egg problem, but for data. And there's like one way how you can think about it is through the read model. So if you, let's maybe take a step back and think about your like your typical 3-tier app, like your Rails app, etc., where you typically have like one Postgres database and you have a CRUD API endpoint in front of it. And with that database, you, without discriminating further, you just like read from it and you write to it and you mutate the entire thing. And this is like typically you don't in your traditional web architecture, you don't think too much about the separation of read and write model. And you just have the same database, you read from it, you write from it, and it becomes sort of like this cozy mess. But if you want to be a bit more principled, you can actually think about separating this out. And you think more about like, hey, where does all of this data come from? It comes from like some writes to it in some place. It's like, how does data change over time? And then you store all of this data that you can query it later. And so the querying later, this is where the that's what the read model is. And depending on the architecture that you land on, you can actually separate this out fairly cleanly. So just as those two directions, there's different technologies that embrace different parts of the spectrum. Electric is a really fantastic building block for for that read path thinking, for embracing the read model. And that gives you a lot of benefits, which I'll get to in a second. With LiveStore, I'm going to all the way to the other side of the spectrum and thinking about how do I work with the write model? How do I sync that? And then there's also really interesting technologies sort of that fall in the middle somewhere of that spectrum. Zero being a very notable example. PowerSync, TanStack, Optimistic, so a fairly new project. So they kind of do a bit of both and trying to offer you an attractive trade-off that applies to a lot of applications. So before going further down the path of write path syncing, I want to share a few thoughts on the read path thinking, the read model, when that is a good approach and where challenges may lay. So the benefits of this is it actually is much closer to your traditional web app development. And a huge benefit is that it works with your existing database. So you can bring your existing Postgres database, in the case of Zero, write a few queries. In the case of Electric, write some shape definitions, and then your data happily streams into the client, and you don't really need to change the architecture much overall. And another huge benefit is if your database is huge, you don't need to sync everything. You can just, based on the query definition, based on the shape definition, you can partially sync what you need. However, when you now start thinking more about how do writes work, this is where it gets a little bit tricky. And those challenges, those I've been so concerned about for working on Overtone that I've leaned all the way to the other extreme. And I wanted to go kind of writes first. But common problems that you face there is that the situation happens that you really don't want to happen, which is state diverging, and possibly even in a catastrophic way where you lose rights. Like you filled out a form, you worked on a document, maybe you get an error message, and then proof your data is gone. You really don't want that. And that this doesn't happen, there's a lot of engineering work needed, and that typically falls in your laps with more read path oriented technologies. And going all the way to the extreme that this works fully offline, which was really important for my use cases, makes it a lot harder. And there's sort of this murky middle ground, which is called optimistic updates. And as you pull more in that thread, things tend to get a lot more tricky. The technologies in the middle here, those hybrid technologies, they're going a long way there. But for LiveStore, I really wanted offline support, no asterisks. So that has led me down the path of how to implement that. And a common way to build this is through event sourcing. So a different way to think about this is to achieve something that in today's world actually is put to the test, the great separation of powers. We're not talking about the church in this case, but still about state, not the government state, but more of the state of data, and what you want to separate it from the write operations from events. So that is kind of really what I wanted to achieve. I wanted to freely model my state and freely model my events and derive one from the other. So before I started this entire endeavor, I started with some design goals. And first and foremost, for me, I wanted to have a data foundation that is simple to reason about and gives me a great developer experience. And the easiest way how I could, or the simplest architecture I could think of, is through that separation of state and events. So to primarily think about events, what has happened, like someone entered the building, someone has left the building. Those are events, and from that you can derive state, such as how many people are currently in the building, or where at 3 p.m. in the building. And why that's so cool is when you build rich client-side apps, then you, for example, maybe you build a web app that works in multiple tabs, or in multiple Electron windows. Let's say you're using Notion and you have the same app open in multiple tabs and multiple windows. You don't just sync between your users you collaborate with, but even with yourself. So that's a syncing problem by itself. And I wanted all of this to be as simple as possible. And the only way how to do that is to build a eventually consistent system. And so I needed also a way to impose a total order of those events if we're getting a bit more lower level. And also very important to me is that I want to be able to control my merge conflict semantics. Most sync technologies right now are last write wins, which works okay until it doesn't. And it leads to kind of a catastrophic user intent situation. So I wanted to have a good foundation to model that as well. And yeah, if you think about it, as you're thinking through like how about events, derived state, etc., we've seen this before with Redux, and Redux was always more like on a single machine in a single thread. But if you think more about distributed software, this is where Git comes to mind. And LiveStore is really sort of like the Git meets Redux technology. And yeah, this is what LiveStore is. So LiveStore is a local first data layer based on event sourcing and heavily embraces SQLite for the state management. Is really important, and this is I've actually started with the latter part with the reactive SQLite part. This was previously a project I collaborated on with Jeffrey Litt and Nicholas Schiefer under the name of Riffle. And LiveStore is sort of the successor project to that. It all started with that reactive, like really high performance SQLite that can drive your UI. But now LiveStore over the last 2 years, I've added a event sourced syncing layer. And it's really inspired a lot by Git in the way how you can like pull and push changes. It's also, as I've been building LiveStore, I've been also constantly building out dev tools for that, which helps me with that great developer experience and keeps it easier and simpler for me to grasp. And everything about it is pluggable. So I have adapters for various platforms, web, Expo, Node adapters. There's different compatible sync backends. There's an implementation with Cloud for Workers, Electric SQL, and various framework integrations. So let's take a quick look at a demo. And I need to kind of blaze through this to somewhat stay on track time-wise. So starting with a little bit of data, a little bit of code first. So this is a plain old to-do MVC app with, in this case, with a React binding. This is the entry point here where we're starting out with a LiveStore provider. And that LiveStore provider points to a schema and gets an adapter. The adapter in this case is a persisted web adapter, so where we want to store data locally persisted in OPFS in this case, and we want to point to the schema. And the schema is based out of two parts: the separation of powers, our events and our state. So starting with the events, this is unsurprisingly for a to-do MVC app. We have like a pretty simple domain. We have an event for a to-do being created, to-do deleted, completed, uncompleted, deleted, and so on. And then the state that we actually want to query looks like this. Basically, that we have a single to-dos table. We express this here for SQLite over those various columns. And then the thing that brings it both together is what I called materializers. So you materialize state. And this is where you basically map over your event definitions here. You get your event payload. And then you translate that into database state updates. So you can here use this query builder that's built in, but you can do arbitrary things here that mutates your state. And that's sort of it. That's all you need for this. Based on that describes your schema. And from that, you can then happily use that from within your application. So here in this, let's actually switch over to our app here. So this is where we have like our to-do list, and in this to-do list we have the list. We have some like new to-do this field here, and we have some further state here. And for example, to get the list of to-do items, we're basically just using a query we've defined. The query here is slightly more complex. We're basically using the to-dos table. We're saying like, hey, the to-dos shouldn't be deleted yet, and they should match our filter. The filter here is that we say we want to only show the active ones, the completed ones, or all. So all of this is reactive through sort of a signal layer. And yeah, then we're just getting our to-dos. This is how the read path works. And for writes, we're basically just committing events to the store. And when I'm like, for example, toggling this to-do, this is toggling this to-do is just committing a new event to the store. And that automatically goes through this loop and updates the state transactionally. And while I'm at it, you've seen down here also the Live Store DevTools right away, where you can see like the actual in database state of the app. So as I'm toggling something here, you see this here being updated in real time. And this actually works both ways, and even in a way where you can also see like the temporary state like this, which is still persistent. So as I'm reloading this like persists form state, also like this state here down there. So everything is persistent. So this is the state. And here we can also see the events that happened over time. And so as I'm completing a to-do, you can see here the events appearing. And that is also the events, that's the foundation for syncing, where you can see here we are currently connected to a Cloudflare sync backend. And as I'm doing something, this is happily syncing. I can open the same app over here. So this has now caught up. And as I'm toggling something here, this is fully syncing. And the DevTools even give you a way to like let you pause your current state. So when you make some changes here, and then you resume, this will fully sync up. So this is how you can nicely debug offline situations, etc. So that was just a quick demo. There's a lot more to show that I don't have time for, but just wanted to give you a sense for how this is working. So that summarizes how LiveStore is working in a nutshell in a local only situation where you have your events. Your events are being materialized into state that is reactively reflected to your UI. In this case, React, but it also has solid bindings, web component bindings, etc. And your UI can further commit new events, which are then going in this loop. Everything, all of that is persistent, fully reactive, and built for performance. So the events, just to go through this one more time, you define your events arbitrarily, and then you can use your events to commit them to a store, and that emits those sort of live store events, which are being synced across tabs, but also across users and devices, etc. And to make all of this work, the events need to be ordered, and that is being achieved through like a parent ID mechanism. And it's very similar to how Git works in a way. The state here, the first implementation is reactive SQLite. I'm actually planning to provide other state mechanisms. You could imagine DuckDB or other things in the future. This is like fully integrated. You can just define your SQLite schema definition here, and then directly query it. You see the SQLite DSL here. You could also use raw SQL statements or anything else. The common denominator needs to be SQLite. And yeah, that is essentially, together with materializers, which I've shown you before, that is in a nutshell how LiveStore is working locally. And the cool part is the same system works locally, but it also works across devices and across users. So here, basically, instead of just going through this loop, you additionally, in parallel, also go through this loop over the network here, and you push new committed events to your backend. The backend here is, this can just be your normal backend where you just add the sync handler. And that is super simple. It basically just, the sync handler just needs to like implement a push and a pull handler, which stores and retrieves events from a event database. This can be anything really where you can store your event log. You can store it also server-side SQLite. You can store it in Postgres. You can store it in S3, wherever you want. And that's it essentially. So it's very simple and very easy to operate and very easy to and simple to understand. So just a few more words about syncing. It's all oriented around this push and pull model, which typically just works automatically. So the client is always trying to push new events and pull new events downstream as well. But you could also do this more manually if you wanted to, for example, use LiveStore in a CLI, for example. The sync backend enforces the total order. It allows for concurrent pulls, so this scales very well in terms of a lot of reads, but requires sequential writes. You can enforce your access control business logic rules in your sync backend, and that is like completely flexible. And for all the data, the client is really the source of truth. If you hit any merge conflicts, you can give the events further meaning to define even what is a merge conflict. And then the conflicts are being resolved through rebasing. Rebasing, what you know from Git. And by default, that works as last writer wins, but you can also implement your own custom conflict handler to implement various scenarios. And to my knowledge, I think this is actually the most flexible option in the sync space that really lets you implement your business logic for merge conflicts. I've already mentioned the same sync system is really applied multiple times here. It is applied globally for syncing between devices and different users. That's kind of like what we all think about a sync engine, but it also actually employs the same syncing paradigm between a few additional distributed systems that are essential here, between memory and storage. So if you want to persist something locally, those are not the same thing. There are things that can go wrong. You might close the tab before you've stored it, etc. That's a distributed system by itself. And then also across, like running the same app in multiple tabs or multiple windows also needs to be synced. It's also something that can get out of date and needs to be resolved. And LiveStore's syncing approach like fits to all of those different systems, and it even allows you to implement some functionality on a global level or on a local level. So it allows you to define an event. For example, if we're going back to our app here, this state here, we don't want to have that be synced across those two instances. So if I'm reloading this, this is still here. If I'm reloading that, this is still here. However, this should be synced across both instances. So this is local only state or local only events, and those are global synced events. So that is super ergonomic because in an app, some data should be global, some data should be client only. So I'm running a little bit here out of time. I might not have time to go through like all the meat that I've prepared for my talk. I'll leave some of that for questions, and I'm also planning to speak more in depth about this at the local first conf. So just blazing through at least through some of the titles that to give you an idea for some of the things that are interesting about this is like how to think about schema evolution, really like the separation of how you evolve your read model and your write model. That was one of the motivations for LiveStore, which makes database schema migrations just poof disappear for your read model, which is absolutely wonderful. How event logs are modeled, that's now a thing you need to think through about like access control, etc., and how you break down a larger app into smaller pieces. I've mentioned the first class dev tools, and now rounding out with the pros and cons. starting with the reasons why I think this works well for some apps is that it's like super simple to understand, super reliable, works completely offline, like offline, no asterisks, supports flexible data modeling, schema evolution is a breeze. It's very cheap to operate, which is very important for me with Overtone. And you also get things for free, such as auditability and debugging. It's just super nice. Cons, it doesn't work with existing databases, so only for greenfield apps. Requires you to be somewhat disciplined to do that separation, unlearn a few patterns. And how you evolve the entire app, you might be robbed of some flexibility further down the road. And it might not work for all use cases. You wouldn't build the next Facebook with this. So when to use event sourcing, basically, if you can model your data changes as events, you can segment your events into event logs, and typically that works well for user-centric and productivity apps. When you shouldn't do that is if you just have like social network style, too much data where you need partial sync, or if you only need the current data and you're not interested in the entire history. Um, I have many interesting stories about challenges I've hit that I think are interesting to get into. Many research questions that I would like to get some help on. I think each of them could be a own interesting talk by itself. I'll spare that for the future. LiveStore will become open source in the next month at the local first conf. And this is also where I welcome anyone to get involved, either as maintainers and contributors. LiveStore right now just runs on sponsorship. That's how I'm sustaining myself. And yeah, in the future, I'm planning to also give sponsors extra benefits such as access to office hours, access to the dev tools, etc. And very importantly, I'm looking for design partners. So if you're thinking of building a new high performance app where LiveStore seems like an interesting building block, I would like to talk to you and see whether we can partner up. That was it. I'm looking forward to your questions.
Awesome, Johannes. For the sake of time, the questions are in the chat if you want to engage there, and then we'll get
That
Alex
sounds
on
good.
when you stop sharing. That was an awesome talk, and I love that I can just use it as a database for a local app. Uh, that's something that I've been asking for from other sync providers. Start with just like my one app, one device, and then move up to multi-devices or sync or whatever optional. Next
That's
up,
exactly where I started.
nice. Next up, we have Alex. He's the CEO and founder of Adium, and he's been a wonderful person to have in this community. Regularly run into him in SF, and he has been around the block. I think he basically was Mongo's one of the early hires of Mongo's for a while. MongoDB. I'll hand it over to you.
Hey everyone, glad to be here. I will show you some slides. We'll try to build on Johannes's amazing talk. I think it was a wonderful description of challenges and an interesting solution with event sourcing. But we will approach this from a slightly different perspective. One thing that really stuck out in his talk is the beginning, this list of different technologies. And I think it's very important as like to keep that in mind as we go forward here with these talks. But a little bit about me. I'm a CEO and co-founder of Adium, and we are really working on various data interconnectivity challenges. We actually started with building a data sync engine. It's open source. It works by syncing different databases. But we quickly figured out that that's not what
Sorry, Alex. Sorry to interrupt. Can you stop sharing and reshare again? I see stream failed to
Oh,
load the screen.
I'm so sorry about that.
No,
Let
I
me
don't think
redo
it's
this.
you. I think Discord is struggling with it even after we have. This is really annoying.
How are we doing?
It's still blue screen on my side. Uh,
Mm.
So
Okay,
let me
let's
try
try something
dropping
else.
off and then coming back on.
Maybe I can do this.
It's still not happening. So what I'll have you do is I've pinged you a Meet link and join that, and then I'll have you. Yeah. So we're just gonna adapt and then do Hinnock's presentation first, uh, and then go from there. Sorry about that, everyone. These things happen once in a while. So Alex, if you stop sharing, I'll have you go last after Hinnock's session. All right. So quick adjustment, guys. Hinnock is an ML engineer at Vela. He's been doing a lot of great work, doing eking out every possible performance improvement you can find to get models running performantly. And what today's talk is how you were able to kind of get these things deployed and fine tune them. For the rest, I'll hand it over to Hinnock. Okay, your screen loaded. Luckily, it briefly showed the same error, and I was about to start freaking out.
Oh, okay. It's fine, right?
Yep, you're up and running.
All right, awesome. So I have this cold, so bear with me if I cough a lot. Thanks, Jonas, for inviting me. So I'm Henok. I am based in Ethiopia, Addis Ababa. For those who don't know, it's in Africa, and I'm part of Vela. I do most of the machine learning there. So today we're gonna talk about running big language models. It can be smaller language models or large language models on mobile and web. So the flow is going to be like why run locally and what are the challenges and how to run locally. We're going to see some frameworks and also see efficient fine tunings for this big language models. And then finally, just a very quick and short demo. So So you might probably be asking, why even run locally when you have, fill it in whatever model you use, or like you like, could it be Claude, ChatGPT, Gemini, etc. So for obvious reasons, the first one is like privacy. So user data stays on device when you run locally. It works without internet. There's no server inference charges, and there's no third-party dependence. So these are like very high level reasons why someone might want to run locally. But this comes with challenges. And for example, here on the left, you can see different models like, old models from Google, like BERT, DistilBERT, the T5 text encoders, and also big LLMs like Llama, Llama, and GPT. Now, if you see the parameter change when BERT was released, probably in 2018 or something, it had 110 million parameters. And now we have the Llama 4, which was recently released, and we have 2 trillion parameters. Now the challenge is, when the models get bigger in size, there's obviously they become compute heavy. They need all kinds of GPUs working parallelly to even run a simple inference. And phones and browsers, they have limited RAM, CPU, and GPU. And the other one is they need some sort of compression, or they need some sort of hardware-aware deployment. But how can we run them? So these are a few frameworks that I found today, just piling this up. And there are a few things like the Onyx runtime, the MediaPipe, TensorFlow Lite, OpenCV, etc. So now all of them have primary use cases. So if you want to work on like cross-platform web or mobile apps, Onyx could be the best. If you want to run web apps, MediaPipe might be the best. If you want to work on embedded devices, TensorFlow Lite might be the best. And some have their notable features. For example, the Onyx is very good for hardware optimized stuff, and OpenCV is very good for computer vision stuff that uses extensive vision algorithm. And we also have this Transformer.js, which is you can run language and feature models in JavaScript in the web using the Hugging Face Transformer library. So this is the Transformer.js. So today I'm just gonna give you like some sort of like intro about like the Onyx and the Onyx runtime, and then at the end we're gonna see MediaPipe demo. So the Onyx runtime. So first we have this Onyx and Onyx runtime. So the Onyx is it's an open neural network exchange. So you can see this as a file format, and then like something that runs it as a runtime. So the Onyx is just a model graph layers that's traced using simple inputs, and it also have its own Onyx operators like conv, relu, etc. And then it saves the weights, and then it structures it into .onyx file. So if you have a PyTorch model, if you have a TensorFlow model, it changes that to Onyx .onyx file. And then we have then the Onyx runtime, which is a cross-platform model accelerator. So basically, it loads the Onyx, and then like it will give you efficient and optimized ways to run it. So making big models small, like now we have seen many million parameters or billion parameters of models. So now we want to make them smaller, because once they are tiny, they can fit in the RAM, they can run in browsers, phone, or edge devices. So for that reason, we have quantization. So Onyx runtime supports quantization. So quantization is just compressing the model by reducing the processing number. So let's suppose, for example, you have a 1 billion parameter model, and then you train that using PyTorch. And then when you change that to Onyx, it compresses a little bit when it's changed to float 32. And then you can do some sort of quantization to int8 and int4, and then it better compresses the size by reducing the number of marginal operations or things like that. And then the model size might eventually get into like 250 megabyte or 300 megabyte, depending on like what kind of model it is, etc. So you can have like int4 and int8 quantization. Sorry. So the int8 is usually on Onyx. The int8 is the one that's very stable and is working fine for most or all of the models if you want to quantize. And the int4, it's not supported much in the Onyx, in the current Onyx runtime version. And then the Onyx runtime, it supports this, data types like the int8 and the FP16 and all that. And these are super fast. And then the other things are you can have the Llama CPP to run Llama on laptops and phones, and this is the new GGFU format, which is a lightweight format to run Llama models, which is used by Llama CPP. Now, what can you build using Onyx? So, so there's, for example, an open source model from Facebook Research or Meta, and it's NLLB, no language left behind. And they have different set of parameter models. So the highest is like 54 billion parameters, and then there's 200 million, 600 million parameter distilled version model. So if you want to run that model offline and do some machine translation locally in your app, basically you can use Onyx to do so, and the Onyx runtime. So what it does is for Android and iOS, for Android, it uses a system level API for running the neural networks. So it lets the model run much faster and using the phone hardware acceleration. And then for Mac, iOS devices, it uses the core ML, which is Apple's framework for ML inference on iOS devices. And by doing so, you can just basically change the PyTorch model to Onyx, and then using the Onyx itself or other libraries like Optimum from Hugging Face, you can change them to a small variant of the Onyx itself, like the quantization that we have seen. And then you can basically use that into Android, iOS, or web, or even like desktop and servers. Like you can basically run a super fast, just Python CLI code just to basically make inference. And the inference time is very, very decreased from, I'm sorry, from the original PyTorch model. So example here is you fine tune a model. So basically, if you are running, a company or something, the odds of not fine tuning, if you are using, some sort of ML model, the odds of not fine tuning it for a specific purpose is very low. So you fine tune that model, you export it to Onyx, you run fast inference in Python backend or Android, iOS, or the. Now, like I said, the odds of fine tuning might be low if you are working on these models. But the issue is big models like Llama, Gemini, or DeepSeek, they are too large and heavy to fine tune. So we have this thing called low rank adaptation. So low rank adaptation is, for example, let's assume you have Llama 7B model, so which is 7 billion parameter model. So if you do full fine tuning, that means you're gonna use all the 7 billion parameters and all the trainable parameters, and the memory that it uses is typically 12 times the model size in the memory. So if the memory size is, for example, like 10 GB, then it needs at least 120 gigabytes of memory used, and then there's also the GPU. Now what LoRa does is it only uses a small subset of parameters, and then it typically introduces between 0.1 and 2 of the full addition, the full model parameters. So if you have, for example, a 7B model, a LoRa configuration of 16 or 64 might add between 1 million and 10 million trainable parameters. So if you compare that with the 7 billion, that reduces the device we're going to fine tune or things like that. So even now, maybe doing LoRa fine tuning it could be a little bit hard on web and mobile devices, but for very, very small devices, for very small models, this might work. So this is how it works. So in the left, you have the regular fine tuning. So the pre-trained weights are, for example, let's take Llama. So the pre-trained, and you want to fine tune it for let's say medical question answering or something like, or financial data. So the pre-trained weights are the original Llama models, and the weight update is the thing that you get after fine tuning it, and then you add that up in inference, and then you give the output. Now what LoRa does is you have the pre-trained weights, which is the original Llama, but instead of the weight update, so in the full fine tuning, the weight update is just the entirely 7 billion model, and then in LoRa it just uses A and B, and then the A and B are very small matrices, and then they will be as they will act as the weight update. Now they are still Now A and B, they are like initially like back propagation or something. They are set initially to random values, and then they learn through the training or the fine tuning. And then these are very, very tiny matrices compared to the weight update. And then you add that up to the inference, and then you get the output. So even though we have talked about Onyx, I want to show you how or to try it out how you can use MediaPipe, which is sort of the same thing that uses WebAssembly and web GPUs to run German models on the web browser. Um, so, so this is basically, so MediaPipe is from like a Google Edge, and most of these frameworks that I mentioned are all open source. So this is practically what the example is about. So I can't run it. Okay, so it says loading the model. So this is where the WASM takes a little bit time. So it's just a simple personality predictor, just a fun demo to show. And let's see. And then it tries to use the JAMA 2 billion model, and then it gives me dispersion probabilities and things like that. So what this does is it basically uses this JAMA 2 billion model. So the size of this model is like around 2.5 gigabyte, and then it's GPU supported, and then it's int8 quantized. And then we have this .bin or .task file format, which is after you do after you find like fine tune or something like that, you have to change it to a format that it supports. So currently, uh, MediaPipe, for example, supports .bin, .task, other variables, other like model types, and then you can use those. Uh, you can use things like light RT and other ways to basically change the model type from PyTorch or TensorFlow to this, and then you can basically run this model. And then you have to do obviously quantization. Otherwise, it will be very big to run even in the web GPU or in the browser. And this is instruction to the model. Um, and yeah, I know this was super fast, but like I want to just give you the idea of working and running local LLMs and what are the possible ways of doing so. So I hope you got something out of it. Thank you.
That was a cool presentation. I almost half expected to see neckbeard on the personality detector, local first and AI. All right, now back to Alex. I hope you guys will bear with us for a little bit more. Over to you, Alex.
Yeah, thank you. And sorry, guys, about all of those technical difficulties beforehand. We solved it by proxying my video through Google Meet, and Jans, back to you. So we'll see how that works. But just to make sure we rehash a little bit from the beginning, we will build on the end of Johannes's talk here. And what I would love to talk about is where I think the future of data infrastructure is going, why I think APIs will be important, and show you a cool demo. Now, a little bit about me. One thing, I'm a CEO and co-founder of Medium. Our goal there is solve data interconnectivity challenges. Before that, I was in MongoDB, and before that, I was in Motorola Solutions doing embedded engineering. Now, the interesting story that I want to share is the story of 2006. I'm sure some of you remember before that, when we needed to deploy a server, we would actually go and sign a contract with a data center, and we would allocate a server, or you would have this thing running maybe under your table, like on a physical box. But in 2006, everything changed, and on one way to look at it is to think, hey, like it's cloud computing. But the other way to look at it was that it was really, really high demand. That's what prompted the change, because the change came from AWS, or specifically from Amazon, where they needed a lot of those things and they need to operate them very efficiently. And so they had to build this EC2 thing internally that they actually started working, I think, in 2003, and then they rolled it out in 2006 to the world. So it was the demand. Now, what we're experiencing right now, we're experiencing also a change in demand, because before, if you were building, let's say, a local first app, or you are building an enterprise service, you would need to know and assemble a lot of those building blocks. Obviously, it helps if there are different websites and resources where you can go and learn more about those building blocks, but it's kind of hard and it's still a lot of manual labor to figure out how you're going to use zero sync or how you're going to integrate live store in the application. And it's bearable because we know that, okay, you hire a person that knows how to do it and they just do it. But that's not what is happening right now. What's happening right now is the trend that AI is starting to write or help write applications. It's not just about a really smart human, it's about what AI can and cannot meaningfully accelerate and how much that will produce a change in demand. And it will probably produce a lot of change, right? So for every 100 of applications and services right now that we see in companies, mobile applications, etc., there will be another 1,000 potentially. And that will all still be built on the foundation where somebody has to make those decisions and assemble all of those building blocks together, right? And I mentioned some of those things here, and this is not even scratching the surface, right? Just think about observability, operations, security, like even something as simple as trying to build a local first application with all the great tools that there are out there, it still will take time to figure out how to build it if you want sync across different devices and you want to sync it to some central database like Postgres or MongoDB, what have you. Now, the other side of this is not all of those new applications and services that's just like random things. All of them are kind of SaaS. And I think where the future is going is that every AI agent, every interaction will create a new SaaS. So this is a screenshot from a platform called Thesis. Uh, I know the founders, and that's one of the examples what they call generative UI. So you can imagine that instead of you even coding something or asking somebody to code and create a service for you, you just go and say, this is what I want to see. Give me this UI that works with that data. Done. But that's a SaaS. That's a mini SaaS. Now, if all 20 people on this call go and do it, now we have 20 SaaS applications. And you can imagine how that gets really tricky at the data layer, especially if we start adding this to an enterprise, not just simple use cases. And that's really uh, a good, very high level example of what it may look like, where you have on one side all of your data infrastructure, you have ETL processes, different expressions of data stores, data lakes, and whatnot. And on the other side, you have consumers, which is business consumers, people that actually use, even if it's an application, they still use it for something, except that now you will have a lot more consumers. So what I think will we will need is a different way to express this interaction between the right side and the left side. Right now, interaction is really that you go and you query the database if you need data. And everything else behind the scenes is just sort of plumbing that happens to be there, that somebody really smart happened to architect it, the other really smart person implemented, and the third really smart person supports it. But that's just not going to scale if the right side is multiplied by 100 all of a sudden. So you need a different way of interacting with the system where you don't need to go to the database directly, or you have some other ways of solving this problem. So the way we are thinking about this problem is APIs. It was a big thing back in, I guess, 2010s. And then we also a lot of cool abstraction layers, microservices, and also abstraction leakage, ORMs, and lots of cool things happened. So I think that we wanted to explore at Adium how we can try and implement a different kind of API that helps users work with their data. And we built what we call a DAPI. It's based on gRPC and protobufs. In essence, it's a pretty simple data abstraction layer or thin backend as a service. You can also call it that way. And what it does based on your proto file definition, which is just a definition of your services and endpoints and the configuration that tells what those endpoints do. It allows you to connect to your databases via gRPC or MCP, which we also natively implemented for your AI agents. In effect, this is an exploration of what it would like if you had an easy button to turn data into API, but not a CRUD API, but a declarative logical API, where you can express what you want those APIs to do on perhaps a less granular level than simple CRUD. And we have a little demo. I will show you right now what that looks like, but you can also use it yourself. It's publicly available. It is free. You don't even need to bring your database. So we have a shared MongoDB instance just to play around. And because it's just an experiment, it's only available to the first 50 users, first come, first serve. So you guys are actually the first ones to know about it. But I will show you what this thing would look like. So here, this is the interface. And if we want to create a service, this is what it would look like. So this is an already created service. It has security enabled by default. We already have some tokens for different roles. We have the API key, we have the gRPC URL. And if we wanted to create a new one from scratch, this is how confident I am, right? I can just delete things live. We would just upload the protobuf file, we would upload the config file, and then we would deploy. Now, let me show you what those files look like real quick. So give me 1 second. There you go. So you should be able to see now my VS Code. If you are not familiar with protobufs, it might be a little scary, so I apologize for that. But it kind of makes sense if you look into it. Here we just define that we have a movie service. Let's suppose we have some movie data in our backend. We say that we have 2 endpoints that we want to serve. We even tell what those endpoints are. And then we just express the structures, what those endpoints are serving. As simple as that. And then the config file, we go in the config file and we say that for this movie service, we go to this specific database in collection in MongoDB. And for these endpoints, for example, for list, we do a find. And for getting movie with comments, we do something more complex, aggregation, because comments and movies, they just ended up separate. And for both, for both endpoints, we use authorization, and we require the user to be a user. Now, why is this cool? Like, whoa, what's so interesting about this? The interesting part about this is that we can now build applications without worrying about our data layer. And this is hugely important when we are trying to do such a thing like vibe coding. So previously, if you vibe coded something, as in like try to build an application from scratch with Replit or Claude, you end up with potentially multiple data models. They are not really good at rationalizing your database architecture. And here we can just tell Claude that's what I did. Build me an application just for the backend, use this proto syntax, and it builds me an application. I'll show you in a moment what that looks like, but we can also do some other things. We can now go to Claude and ask it about the data, because we also support native MCP integration just for fun. And those comments that you've seen in the in the protobuf file, they are the descriptions of the services. So here we can ask Claude what movies are available, and it triggers the endpoint list. Or we can ask Claude, give me more information, give me some comments and what do people say about it, about a particular movie. And it goes and triggers the other endpoint. So it's pretty smart about this. It can also do more intelligent things like data manipulation and whatnot, but I'll skip that for now. And the application, if you wanted to see what that would look like, here you go. That would be, sorry, that's not the right one. Okay, it's too difficult to find it. There you go.
You haven't shared it yet.
Okay, we'll skip that then. We'll
Okay.
just go back
Maybe put it in
to.
the link. Put the link in the chat and people can explore it.
Yep, I'll share it later, but it's not the important part. I think the important part is it's available, the demo for people to try and use. And you are more than welcome to share your feedback. I'm actually really curious to see how we can help to integrate this more with the local first approach, and maybe how this can be used for mobile, or maybe how we can like put those APIs closer to the edge. So right now everything is open. We have tons of cool ideas that we are working on, and I think that uh, I think that's an exciting way of allowing us to bridge this gap between all of those new developments that are happening in AI world and the data layer, right? Where the data layer is becoming a more comprehensive thing rather than just, hey, it's a bunch of databases potentially connected via different kinds of things. So thank you guys. Uh, I appreciate the attention, and if any questions, ask in the chat, ping me. I'm available here in Discord. We have our own Discord chat. So happy to connect.
Wonderful presentation, Alex. And it is kind of great to